Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. How Lavoisier revolutionized chemistry, the scientist who named the elements and changed the world. Imagine a person turning seemingly disappearing matter into something eternal. No, not a magician, but an 18th century chemical genius, Antoine Lavoisier. Now, Lavoisier didn't wear a cape or wave a magic wand. Instead, he had chemistry lab tools and a brilliant mind that changed the world. What this man did was nothing short of revolutionary. Not only is he called the father of chemistry, but he's also a sort of scientific superhero who completely transformed the way we understand chemistry. From theory to practice, he redefined the very building blocks of matter and catapulted science into a new era. Even today, his discoveries affect every detail of our lives, from the air we breathe to that glass of water you drink in the morning. Lavoisier's childhood wasn't spent in some dark, underground lab, playing with dangerous chemicals. No, he grew up in a wealthy Parisian family. Picture this: instead of eggs and bacon for breakfast, imagine sitting at the table discussing natural philosophy, surrounded by books. Sounds pretty sophisticated, right? Lavoisier's father was a lawyer, and his mother came from a noble background. Despite the privilege, they didn't push him to follow the family's legal path. In fact, they encouraged him to pursue academics. You want to be a chemist? Fine, go for it. Now, this kind of freedom wasn't all that common back then. Lavoisier's education was top-notch. He attended an elite school in Paris, where he studied natural philosophy, chemistry, and mathematics. Without a doubt, if not for his education and the personal tutors he had, Lavoisier might not have reached the heights of scientific achievement that he did. After all, his school days were far from average. He had access to knowledge that few could even dream of back then. His time in school made it clear chemistry would be his stage. And let's talk about Lavoisier's natural talents. He wasn't some nerd hiding in the back of the classroom, he was the classroom superstar. Every time he spoke, it was like a standing ovation from his peers. But this wasn't just a product of some inherent genius, no, it was the result of hard work, countless hours spent conducting experiments, and deep thought. Lavoisier's talent shone through because of his relentless pursuit of knowledge. In general, Lavoisier's upbringing wasn't exactly grinding through adversity. In fact, it was relatively privileged. But this educational advantage laid the foundation for his future success in the scientific world. Imagine a kid growing up in a bustling Paris, exposed to a world of knowledge while exploring the shops and markets of the city. That's the kind of environment that set him up for greatness. Now, Lavoisier wasn't just about doing experiments. Oh no, he had a whole scientific empire to manage. He was like the CEO of his own lab at the French Academy of Sciences and also the chemistry wizard at home, especially with his wife, Marie-Anne Lavoisier. You've probably never heard of her in most science textbooks, but trust me, she was no mere observer. Lavoisier's early career was impressive to say the least. He took on a prominent role at the French Mining Academy, a major academic institution that focused on the study and exploitation of mineral resources. To be involved in such an institution meant you were on the path to shaping the future of industry and science. Lavoisier wasn't just a professor here, he was also deeply involved in cutting-edge research and resource exploration. He effectively blended chemistry with engineering, pushing forward mineral research in a way that many scientists at the time couldn't. But the real star in his lab wasn't just Lavoisier, it was his wife, Marie-Anne Lavoisier. She wasn't just taking notes in the background, she was a true partner in every sense of the word. Marie-Anne was deeply involved in the experiments, often providing valuable insights that helped solve complex scientific problems. In fact, many consider her the unsung hero behind Lavoisier's groundbreaking work. She wasn't just a wife, she was a highly educated woman with an impressive grasp of chemistry. In an era when few women had the opportunity to pursue such knowledge, Marie-Anne's contributions were extraordinary. Her support and intellect helped Lavoisier focus on the work that changed the world. If Lavoisier was the star of the science world, she was the behind-the-scenes mastermind, ensuring the experiments ran smoothly. Lavoisier's influence in the scientific world wasn't limited to just his lab. He was at the heart of the French academic scene, deeply involved with top-tier institutions like the French Academy of Sciences. At a time when chemistry was considered a young science, many saw it as unworthy of being grouped with older fields like physics or astronomy. But Lavoisier's meticulous experiments and groundbreaking publications earned chemistry a seat at the table. He wasn't just working in isolation, either. Lavoisier collaborated with leading scholars across Europe, exchanging ideas and advancing science together. Picture a scene where the brightest minds of the time, chemists, physicists, astronomers, are in a room, eagerly discussing the latest breakthroughs. That's how chemistry began to gain legitimacy and respect. What's more, Lavoisier's discoveries weren't just important in the world of academia, they were game-changers for Europe's industrial revolution. His work on oxygen and combustion fundamentally reshaped our understanding of the burning process, providing the theoretical foundation for the industrial processes that followed. The knowledge he helped unlock powered the future of industry and technology. But what truly set Lavoisier apart was his show-me-the-data approach to science. He didn't rely on abstract theories, he relied on experiments to prove every hypothesis. This obsession with testing and validating ideas turned chemistry into a truly empirical science. His approach is what we now call the scientific method: testing, observing, recording, and refining. Lavoisier wasn't just a chemist, he was a forward-thinking pioneer. His work wasn't just about understanding how the world worked, it was about shaping how science would evolve. He believed chemistry wasn't just a field of study, it was a tool for making real-world changes. Each experiment was a stepping stone to creating something new, something practical. So, if we look back on Lavoisier's career, it's not just about his academic achievements, it's about the far-reaching impact he had on society. From his role at the Mining Academy to his partnership with Marie-Anne, Lavoisier wasn't just shaping the future of chemistry, he was helping to steer the entire course of history. Now, picture this: you've got a piece of wood, ready to roast over the fire. As it burns, it disappears. Gone. But what's left behind? Ash and smoke. Now, you might think this is magic, but it's not. It's chemistry. What Lavoisier discovered was that fire doesn't just make things disappear. It's a chemical reaction that transforms matter, not a mystical vanishing act. Lavoisier's discovery that mass is conserved, nothing disappears, it just changes form, was a game-changer. Before him, people believed in something called phlogiston, the idea that burning released a magical substance. But Lavoisier proved otherwise with hard data and experiments. The material didn't just vanish, it changed into ash and gases. It was science, not magic. This idea that matter can't just vanish, but instead transforms into something else, laid the foundation for modern chemistry. It was the birth of the principle of mass conservation. And this wasn't just about proving old theories wrong, it was about providing a framework for all future chemical research. And then there's his work on oxygen. Lavoisier was the first to show that oxygen is the key to combustion. Forget the idea of a mysterious fire element, oxygen is the star of the show. You might think it's nothing special after all, it's invisible and all around us, but without it, burning wouldn't even happen. Lavoisier's experiments revealed that oxygen is what fuels the fire, turning what we thought we knew upside down. Lavoisier's discoveries weren't just academic exercises, they were the seeds for the industrial advances that followed. His experiments proved that chemistry wasn't just a science to study, it was a tool to build the modern world. And this is the legacy of Antoine Lavoisier, the man who turned chemistry into the foundation of modern science. Before Lavoisier, people believed that burning was caused by some mysterious fire element being released into the air. It was a widely accepted idea. But Lavoisier didn't just shake things up, he took it a step further. Through careful experimentation, he proved that oxygen was the key player in combustion and publicly shared his findings, debunking the old, faulty understanding of fire. And that's how the term oxidation entered the science lexicon. Oxygen, once a humble background character in chemistry, was suddenly thrust into the limelight. To further back up his theory, Lavoisier conducted a series of rigorous experiments. He showed that chemical reactions were about substances interacting with each other, not just simple physical changes. Take burning, rusting, or decay, those processes? They all involve matter reacting with oxygen, releasing energy, or forming new substances. They don't involve matter mysteriously disappearing or transforming into something we can't see, as people once thought. But Lavoisier didn't just compare two substances to see what happened. He used complex, innovative equipment to capture the details of these reactions. For example, in his closed container burning experiments, he could clearly see the changes in mass during combustion. He measured the changes in the mass of gases and concluded that mass is conserved in chemical reactions: solid, liquid, or gas, even the air we can't see. Without these groundbreaking experiments, we'd still be stuck wondering what this fire element was, scratching our heads over simple combustion phenomena. Thanks to Lavoisier's careful research and clear conclusions, we finally understood one of nature's most basic laws, the law of conservation of mass. This law remains one of the cornerstones of physics and chemistry to this day. And Lavoisier didn't just stop at experiments, his theoretical breakthroughs were just as brilliant. Not only did he explain how oxygen reacted with substances, but he also proved its crucial role in chemical reactions. This completely transformed the way people understood combustion. Oxygen went from being an invisible background player to the main act in the chemical drama. Through his work with oxygen and its reactions, Lavoisier not only changed the scientific world's perspective but also laid the foundation for modern chemistry. So, when you think about it, Lavoisier's contributions weren't just a string of experiments, they were like opening the door to an entirely new understanding of science. Now, let's talk about water. You drink it every day, but did you know that water is made of two gases, hydrogen and oxygen? No magic, no aliens, just basic chemistry. Before Lavoisier, people thought water was one of the four elements, right up there with earth, fire, and air. It was like the old four horsemen of science, seemingly unshakable, but actually built on a shaky foundation. That is, until Lavoisier used his experiments to prove the new chemical formula, H2O. Suddenly, the ancient four-element theory came crashing down. Lavoisier didn't just talk about the composition of water, he proved it through experiments. Here's how: he burned hydrogen, combined it with oxygen, and created water. Simple, yet groundbreaking. By measuring the ratios of hydrogen and oxygen, he showed that water wasn't made of some mystical substance, but from two common gases. This completely obliterated the idea that water was one of the ancient elements. This wasn't just about water, it was about breaking down long-held misconceptions about elements and chemical reactions. Prior to Lavoisier, chemists had been stuck thinking of water as some mysterious, unexplainable substance. But Lavoisier's clear data and experiments showed that water was just a product of hydrogen and oxygen joining forces, nothing magical about it, just chemistry at work. But Lavoisier's genius didn't stop there. This discovery opened the door to the study of chemical reactions involving gases. Hydrogen, a gas most people think of as just a gas, became crucial in explaining not only water but also other important chemical reactions. It's funny, because hydrogen doesn't look impressive, it's invisible, odorless, but in Lavoisier's hands, it helped uncover some of chemistry's most important secrets. The hydrogen discovery wasn't just an interesting side note. It opened a whole new chapter for the field of chemistry. Even today, hydrogen plays a critical role in things like fuel cells. Lavoisier's experiments laid the groundwork for technologies that are now being used to power everything from cars to green energy solutions. Even though he didn't have modern high-tech equipment, his simple, yet rigorous methods unlocked the mysteries of these complex chemical phenomena. So you might ask, why does Lavoisier's water discovery matter to us today? Well, far from being just an academic exercise, it played a pivotal role in advancing technology. For instance, hydrogen's role as a clean energy source? That's a direct result of his work. His research continues to inspire chemists working in energy, gas reactions, and more. What's even more impressive is that Lavoisier didn't just challenge old ideas, he set a new standard for how science should be done. His emphasis on careful, data-driven experimentation and questioning established assumptions pushed the entire scientific community to rethink how they approached research. And today, many of the technological advancements we take for granted owe a debt to Lavoisier's foundational work in chemistry. In fact, when you think about it, Lavoisier didn't just solve a chemistry problem, he opened up new directions for the entire field. His work didn't just stay in chemistry classrooms, it spilled over into industry, especially in areas like chemical manufacturing and energy production. His relentless challenge to outdated theories and his commitment to scientific progress is what drove these revolutions. Lavoisier's discovery of hydrogen-oxygen synthesis didn't just change how we think about chemistry, it shaped the future. Even today, scientists are still exploring hydrogen as a clean energy source, and it all traces back to his pioneering research. So next time you take a sip of water, remember Lavoisier. Not because he gave us magic, but because he revealed the true chemistry behind water, turning a mystery into a science lesson that still shapes our world. Imagine this: the world of chemistry was once like a chaotic marketplace, everyone speaking a different language, and no one understanding each other. Enter Antoine Lavoisier, who basically threw the ultimate scientific bombshell by naming gases like oxygen, hydrogen, and nitrogen. But he didn't just pick random names, he gave them meaning, making it easier for scientists around the globe to understand and communicate. Let's talk about the name oxygen. Lavoisier took the Greek word oxys, which means acid, because he discovered oxygen's key role in creating acids. As for hydrogen, he borrowed hydro, meaning water, since combining it with oxygen forms water. Through these names, Lavoisier didn't just label elements, he gave us a system that described their very essence, what they are and what they do. Think about it: Lavoisier didn't just name these elements, he brought order to the chaos of chemistry. No more confusing debates like, is this the hydrogen gas I'm talking about, or the one you mean? Now, every chemist could speak the same language, making collaboration way easier. This Lavoisier language turned the chemistry world from a mess into a well-organized marketplace where ideas could flow freely, and scientific progress sped up. But hold on, naming elements wasn't the end of it. Lavoisier established rules for naming, two simple, clear names that tied to the properties of the elements. He made sure that the next scientist to discover a new substance would know how to give it a name that made sense. His system became the backbone of chemical naming, making it easier to communicate discoveries across the globe. Fast forward to today, and we're still using Lavoisier's system. You say H2O, and everyone knows you're talking about water. That's not just a formula, it's the legacy of his clear, logical approach to chemistry. When you read a textbook or research paper, chances are you'll see that same unified naming system. It all goes back to Lavoisier's naming revolution, which helped turn chemistry from guesswork into a precise, predictable science. And it didn't just stop with naming elements. Lavoisier's system reached far beyond. He helped standardize terms for chemical reactions. Words like acid and base weren't random anymore. They became part of a structured language that chemists used in labs, classrooms, and conferences. This helped make scientific discussions more efficient, pushing the global scientific community forward. But Lavoisier didn't just leave his mark on academia, his ideas helped shape the entire chemical industry. With standardized terms, chemists and engineers were able to work together more effectively, making processes like manufacturing and production far more efficient. From mining to steelmaking, the Industrial Revolution was built on the principles Lavoisier laid out. Imagine trying to run a steam engine without understanding combustion or gas reactions. Lavoisier's insights were foundational to that. Without Lavoisier, we might still be using outdated energy sources. He helped turn chemistry into a tool for technological progress. From steam engines to rockets, his work laid the groundwork for modern industry. It's not an exaggeration to say that without his contributions, we might have been stuck in the past for centuries. On top of everything, Lavoisier's influence on chemistry education is still with us today. He took chemistry from chaos to order, transforming it into a scientific discipline that's taught in classrooms worldwide. His experimental methods and approach to understanding chemical reactions are still the foundation of what we learn in labs today. And let's not forget about the everyday impact. From frozen foods to energy sources, much of our modern world relies on the chemical principles that Lavoisier pioneered. His work continues to influence everything from hydrogen energy to fuel cells to even the search for alternative energy sources. But here's the kicker: Lavoisier's life was full of irony. The same man who revolutionized chemistry was executed during the French Revolution. As a member of the aristocracy, he was seen as an enemy of the people. It was a tragic end to a brilliant life. Lavoisier didn't get to see the world he helped create, but his legacy lived on, continuing to shape science for generations. Even though his life ended tragically, his work didn't. Lavoisier's experiments, theories, and methods still form the backbone of modern chemistry, physics, and biology. Every time you use chemistry in your daily life, whether you're lighting a match, boiling water, or reading a textbook, you're using something Lavoisier helped create. So next time you drink water, light a fire, or study in a lab, take a moment to thank Lavoisier. His work didn't just change chemistry, it changed the world. And who knows, the next big scientific breakthrough might come from someone walking the same path Lavoisier laid down centuries ago. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.